Hello, Vishnuvardhan. Good morning.
Good morning, sir.
Hi, Latesh. Good morning. Jeevan. Morning.
Good morning, sir.
Morning, Ravi Trayani.
Good morning, sir.
Good morning, Professor Suresh.
Hi,
How are you?
sir. Had your breakfast, sir?
Oh, I had. Thank you. And how about you?
Just now, sir.
Oh, that's nice.
Yeah. So actually today here in Karnool, Ganesh immersion is going on.
Oh, I see.
Yeah. So have you ever been to this kind of occasion here, sir?
In Karnool,
Yes, sir. Exactly.
um, don't recollect in Karnool, but probably I would have attended in Hyderabad.
Okay. Okay. Almost similar kind of things happen here, and even it would have huge response actually.
Right, right, right.
Yeah.
And I hope all of those statues are now eco-friendly, made with
Uh,
clay or something.
yeah. But not all of them. To some extent only.
I see.
Because people are going like year by year on year, they're trying to increase the height, increase the size and everything, right? So in that scenario, definitely it would not happen.
Right. Hopefully.
Yeah, sir. So I guess somewhere like 15 students have joined.
Right. I see that.
Yes, sir.
16 now. It's going up. Maybe we'll give 5 minutes. Or
Yes, sir.
do you
Please, sir, please.
uh, wait for 5 minutes or start?
Sure, sir, sure.
Uh,
Dear students, please inform your friends to join quickly. Sir has arrived, right? So please inform them to join immediately.
so the students today are joining from their respective homes or rooms.
Exactly, sir.
Uh,
So generally every Saturday, like it is a working day for them, sir.
Oh, I see. So
Uh,
would you like to move the so let me take a step back. So from 10:30 through 12 o'clock, do they have any classes?
yes, sir, exactly. 10:40. It will be like 10:40 to 12:20, sir.
So 10:40 to 12:20 is the break, or they have a class?
They have class, sir.
Okay, then we have a clash with our class session, right?
Yes, sir. Yes, sir. No, it's not like that, sir. Our session will going on even if they don't have like class or if they have the class.
I see.
If your
Okay.
session is scheduled, they will be attending your session. If not, they will attend the classroom.
Okay, so anyways, I don't know the dynamics of sessions these days in the
Yes.
school, colleges or school. So if you would like, we can move this to either early or later on Saturday.
That's fine, sir. I mean, like, better instead of 10:30, we can start at 10:40. Because from 10:10 to 10:30, 10:40, they will have a tea break, sir, actually.
Okay, we'll start at 10:45 then.
Yes, sir. That should be fine then.
Yeah, I've scheduled the call from 10:30 and I've shared with you and made you the co-host.
Okay, sir.
And automatically recording as well now will start for all the sessions, Saturdays
Oh,
and Sundays.
okay, sir.
I'll move that to 10:45.
Fine, sir. Fine, sir.
It is been sent to your calendar as well, GPREC calendar.
I received, sir.
Right.
Yeah. So I thought of you not to wait for that 10 to 15 minutes, sir. So that's why I told you, like, if it is possible to connect from 10:45, that would be fine.
We'll do that. We'll do from 10:45. The whole idea is that the students are able to join in and they pick up some bites and the nuggets of knowledge, right?
Yes, sir. Yes, sir. Definitely.
Right.
Yeah, sir.
So we have another 1 to 2 minutes. Meanwhile, somebody sent a message. Okay, that's the read assistant. So anyone, students, do you guys have any questions or did you come up with any questions for the project? It was a lot of information yesterday, but it was a complete overview in terms of why do we have to think and understand dimensionality? What is the significance of dimensionality in machine learning? And how does that impact the efficiency in terms of be it training speed or the time it takes to train the model or the burden of huge or vast data, vast dimensional data combined with the data samples. So we went through those. And of course, the impact of reducing the dimensions or the dimensionality of the input data or the training data. So I hope you had a chance to go back and recap and had a chance to start putting the code. I would like to go over the code today exclusively. Maybe I'll take 5 minutes to summarize the steps of dimensionality reduction, or rather the PCA, the principal component analysis. What are the steps of this analysis, which is a SOP, or standard operating procedure in any machine learning algorithm that employs PCA. And then the rest of 1 hour or so, we'll go through the code, and I'll also pick students randomly and ask them to explain that line of code by looking at the shared code, right? And then I would also like to spend as much time as possible on the Q&A, interactive questions and answers, or to answer your questions. That is what I was thinking and planning for today's session. And if I can remind all of you, or rather re-emphasize, this is the model that I would like to follow for the rest of the topics, another 7 to 8 algorithms as well. So if you have any suggestions, or if you feel there is a different way of approaching this or using it, all of you are welcome to share your thoughts, inclusive of you, Professor Suresh.
Yes, sir, got it. So yesterday you explained the code on the platform like Visual Basic, right, sir?
Visual Studio Code is the IDE.
Yes, sir.
Visual Studio Code is the IDE, the integrated development environment.
Sir.
And then the plugins are the Python plugins or
Sir.
extensions.
Okay,
and
sir.
the Jupyter Notebook plugin as well. It's easiest integrated development environment for any beginner of machine learning.
Yes, sir. So here I have a request for you, sir. It's better if you could again repeat that how to use that IDE, because like most of the students are not aware of that.
Okay.
Anyhow, they are new for Python too, actually. So parallelly, they are like studying both this, what I can say, Python libraries and as well as the subjects, sir.
Sure. I keep that in mind and try
Yeah.
to address the fundamentals behind each line as well.
Yes, sir. Yes, sir. That's what that's my request from my
Sure.
end, and
Definitely.
and hope the same might be expected by the students.
Okay.
Yeah, yeah. That's what, sir.
I would like to know if how many of the participants of this program, guest lectures program, have already installed Visual Studio and Jupyter Notebook extension. Can somebody say address from student side?
Students, you can answer this question. So as sir asked, anyone, like you can unmute yourself and you can answer.
Sir, actually, we have done the project in Google Colab, sir.
Okay. But I was asking if someone has used or installed the Visual Studio and Jupyter extension.
I guess it will be no, sir, because the like as they are into just second year only, they are not introduced with these kind of IDs.
I see. So a couple of things here, students and also professor. Google Colab, the collaborative environment, which was principally meant for research projects, and it's very, very good. You don't have to worry about the installation issues. That dependency is missing. This dependency is missing, and it gets stuck with some runtime errors. However, while it is free, it also has got limitation. Particularly, you will get micro compute machines. The CPU, essentially they call them tensors. In fact, you don't even get a tensor, you get a micro compute, which is like few gigs of clock speed and probably some 4 to 8 GB of RAM. While it is good enough for the data set that we handle, but if this data set goes a little bit and if the computations are quite intensive, particularly when you have high dimensional matrices involved, it's going to take a lot of time. So I have seen myself that having a Visual Studio on your machine, at least you have a sizable compute, i7 or potentially 11th or 12th or 13th generation with 16 to 32 GB RAM. And of course, SSD will definitely be at least 5 to 10 times faster than the Google Colab. But nonetheless, if you can submit the Google Colab file as well, end of the day, it's a Jupyter file, .ipynb extension, that is good enough. If you want, probably we can run a separate session, but I'll send the visual steps for installing the Visual Studio, Jupyter Notebook, and then Python runtime as well from the Visual Studio IDE, right? Shall we get started?
Yes, sir.
Excellent. So let me share my screen. So like I said, I'll spend a few minutes walking through a recap of the model. Let's see, where is my deck? So this is our deck. Okay. All right. So let's quickly spend 2 to 3 minutes on the PCA analysis, generalize it, irrespective of whether it's eigenvalue decomposition or singular value decomposition. So principal component analysis essentially mean reducing the number of features from the input. So that features mean reducing meaningfully without losing the information from the data, the latent pattern of the data. So note the keyword latent pattern, right? Because you would need to start understanding and appreciate the latent variables, which are the critical components of the diffusion models, right? For the mid-journey type of AIs you might have used that would generate images based on your textual description, the latent variable or the latent pattern is the key concept there. So as well here, reducing the number of columns of the input data or the variables, or also called dimensions, meaningfully, such that we still don't lose the latent pattern of the data, input data, to train our model. So if you have n sets of data, each n points, data points, let's call them, each data point could be a simple scalar, single value scalar, like age of the vehicle, or it could be a vector, meaning having multiple values or multiple columns of features for that data point. You can call as a tuple or row, right? Example, we talked about it yesterday. If you take an electric two-wheeler vehicle, the age of the vehicle, the purchase price of that vehicle when it was new, and then whether the insurance has been there or not, whether there were, how many repairs happened in the past. These are all the various features, various dimensions. These are all for us to predict or infer based on these parameters, to infer what's the current potential market value of that used vehicle. So input, you have an input which could be a scalar or which could be a vector, n samples, and each sample is of d dimensions. In this case, we talked about age, number of, what is the price of the first time, the new vehicle when it was purchased first time or new, and whether the insurance was missing any year, how many repairs took place. So 4 dimensions, right? So, and then you have that data with the 4 dimensions and n samples, let's say for 20,000 vehicles. Then you estimate the mean of that data population sample. So you have to be very careful about these terminologies, because if you are going to build a career in machine learning, take it that they have to be there with you forever. You need to understand what's data sample, what's data population, what's variance, what's covariance, what's correlation, what's eigenvalue decomposition. That's more on the machine learning. These are all statistical terms, key concepts. And we do them every day. We use them every day. Without those terminologies in our day-to-day life, even people in the village use averaging out and all that. How much is it differing, right? So please understand these concepts quickly, early on, and then have a grip on them. So estimate the mean for the input data set. If it is, your data set is a scalar data set, then you will have one value mean, which is nothing but average. What is average? Take all the values of all the samples, sum them up, and divide by number of samples. That's your average, mean. Also called in probabilistic terms, expected value. Again, all these terms are fundamental. They are used day in, day out in any machine learning arena, right? Then you standardize, well, it's not standardization, you either standardize. So before standardizing, so standardization or normalization is nothing but you center the data. We talked about parameters being having different scales. If you average them and take out the mean, the average from each, its respective mean from each sample's data point or dimension, then you're centering the data. And when you divide the variance, or rather standard deviation, which is the square root of the variance of each such centered data, you get a standardized value of that sample. This is essentially to reduce dispersion of the data and also to bring all the data points into a center, right? So, and then you compute the covariance. So if it is a scalar, you simply multiply those two variables, then you get the variance, a covariance. If it is a vector, then you get a matrix. So you essentially, you can see here, so let me use my pen. Okay, so we've got the pen here. So this is the covariance matrix. So when you take each centered sample and multiply that with a transpose, and I hope you know what is transpose. So let's say x tilde equals to a vector x1, x2, x3, xn, right? Then the x tilde transpose would be, any guess, anyone? All right. Transpose is nothing but converting a column to row or row to column. Here it's a column vector. So when you transpose, it becomes a row vector, x2, x3, right? What happened? I think I inadvertently pressed the, yeah, etc. So let's clear this off. Interruptions. All right. So then you compute the covariance matrix when your data is an input vector or rather a vector. And then you do either SVD or EVD, eigenvalue decomposition or singular value decomposition of the R, taking into account the data matrix. Essentially, the vectors or the columns corresponding to the higher value, higher values of either.
Hey, orado.
Right. Eigenvalues, the columns corresponding to the higher eigenvalues of that particular matrix, or the higher dominant singular values when you use the singular value decomposition of that matrix, and the vectors corresponding to those dominant values are the principal directions. So if you can choose to use a cutoff, let's say if you have a vector of d dimensions, which we have taken, you can choose, let's say 90% of d or 50% of d, depending upon the covariance value. You know, it's got to be 0, right? Correlation has to be 0, right? Then they are independent. And those corresponding columns of the eigen vectors that correspond to the higher eigenvalues would be your principal components. And when you multiply each of this eigenvector or the principal component with the input sample that, or your test sample that you have received to predict the output, then you would get the principal component values. It's nothing but a simple linear combination of each principal component with essentially the E transpose. E1 is a principal component, first principal component, transpose of that, So let's write it. E1 transpose X bar would be your first principal component. This would be nothing but, if you consider E1 has D dimensions, then E11 X1 plus E12 X2 E1D XD would be the linear combination of the principal component or the first eigenvector E1 and then the input X bar. So that is essentially, those are the steps for the principal component analysis. Now let's spend another 5 minutes in the project steps. So we are given with a data set of around 3,000 data samples or rows, right? We have seen that row. Let's see that data. That's the AIMS housing data. You can have a lot of plugins that would give you visibility into data. So this has 2,930 rows. And how many columns it has? Anyone?
79, sir.
Absolutely. Actually, it has 81, but there are two columns called index and ID. These are the keywords. So the pandas do not recognize them unless you put some reset, you call some reset method on panda data frame. So if you reset, you would get 80. If you don't reset, you would get 79 columns. So there are 79 columns correspond to one data point. That means there are 79 dimensions, features, columns, fields, variables that a particular input is described. And we need to identify the output, which potentially is the value of that house. So the house is described using 79 columns. You can see here some subclass. This is like your, BDA, the Bangalore Development Authority, or Hyderabad Urban Development Authority, and maybe there is a KUDA, Kurnool Urban Development Authority, which is a government body which essentially collects the property taxes, etc., and describes each property, each house using certain 10 to 20, 100, 30, 300 parameters to value and to arrive at a property tax. In cities, you have to pay a property tax to corporation each year. Otherwise, municipal corporation would come and destroy your property, whether it's a flat or whether it's, they will seal, or whether it's an independent building, right? So there are 79, 81 or 80 parameters. Those are the dimensions. Now we need to, let's go back. So we want to see if we can reduce those 80 dimensions into meaningfully without losing any information to predict the house price given those 79. Can we reduce it to 10, 20, 30, 40, 50, 60? So that's the goal of the project, right? And what has been given to you guys is AIMS housing data. AIMS is I think I talked about it. It's in Iowa City. It's in USA. This data, I think I've given 2006 to 2010. This data was collected by the AIMS local government authority in Iowa State. So you have AIMS CSV file. So what is CSV? What is the full form of CSV? Anyone?
Comma separated variables.
Absolutely. But why do we separate? It's comma separated values, not variables. It has values. But why do we use comma to separate values? Anyone? because it becomes easier. It's like a delimiter, right? Like our enter, when you are writing a Word document, you press enter to indicate the end of the sentence or end of the paragraph. It's easier. It's a delimiter for human eye, visual inspection, right? Or visual convolutional neural network that your eye uses behind your retina, right? The same way for computer to read a data and to treat, oh, it's a value in this data point and there are multiple columns. So CSV, and there are various forms of delimiters that you can use, not only comma, you can use tab, which is around 8 spaces. You can use hyphen. You can use any special character that is not used in your data value, right? Anything non-numeric, you can use as a delimiter, a separator. So as just a little bit of anecdote for you guys, because you would live in, breathe in, live out the CSVs if you become, or if you are going to become a data scientist or a machine learning expert. That's how you get the data most of the times for your training purposes. Of course, there's other mechanism or means, database as well, right? And of course, there are S3 buckets, etc. And then the other code file I've given you guys is the shell code, how to load the data, etc. So let's look at the implementation steps, and then the next 1 hour we'll go through code as well as run the code and answer your queries on each line, right? So most of these steps, I have requested you guys to get a practical insights into the PCA, so that when you print these, then your mind starts thinking and questioning about what are these, how are they related to PCA, and then it starts building the relationship. It brings that attention, which is essentially the key fundamental concept used by Transformers and OpenAI, all these GPTs, called attention is all you need. You guys should read that paper. I think I talked about it in my inaugural session, right? So my intent is that when you try to print these values, then you start questioning and relating them to the principal component analysis, where you would have a better comprehension, better appreciate the significance of principal component analysis. So first, to print, how many columns are there, how many data points or rows are there. Then identify how many of these columns or dimensions are numeric values, continuous values, right? How many are non-numeric and categorical or ordinal values, like we talked about it. Group 1, Group 2, Group 3, or indices 0, 1, 2, 3, etc. And find if there is any value for any of these columns, be it categorical values, be it numeric continuous values. Is there any value missing? If so, find those columns, names. And then if possible, fill those missing values with meaningful values without disrupting your data pattern. We talked about it yesterday, that you can use, if it is numeric value, you can fill in what value you can fill in? If a numeric value is missing, any guess?
So mean or median, sir.
Absolutely. Mean value, right? And if it is a categorical, introduce a categorical value missing, so that probably it can be taken into account during your training part, right? And then standardize the features. Scaling, essentially nothing but normalizing and standardizing. What do we do in scaling or standardizing and normalizing? Anyone want to take a shot?
So reducing the scale, sir.
So what do we do in reducing the scale? Or how do we normalize it? So it's essentially
Sorry,
yeah, go ahead.
So in normalizing, we try to reduce the scale from 0 to 1, sir.
So scale is generic. The process of normalization, and this is again a statistical term. All of you must have heard about standard normal distribution. Normal distribution versus standard normal distribution. Nothing but Gaussian distribution, right? So it's a standardization. Scale is a very colloquial layman term, but the process, statistical process involved is called standardization. What we do there, we talked about it. We compute the mean, and then we deduct the mean from each data point, and so deducted value is divided by what? Any guess? If x is your, let's say xi is your, let's write it here. Xi is your input, let's say. How do we standardize it? So xi is one sample. Let's say you have n samples. So mean, mu, oh God. So mean equals to, mu equals to 1 by n samples, sigma of xi, where I is 1 to n. That is your mean. Now, how do you standardize it? Take the xi, deduct the mean, and divide by standard deviation, which is root sigma square. So that is scaling. It's a layman term, but the statistical mathematical term, an engineering term is standardized, right? And this is for the numeric values, but you can arrive pretty much the same model for your categorical values using essentially there is a different way of plot or using the categorical values. Each categorical value becomes one column, added columns, and then if the value, the corresponding value of that corresponding categorical column value becomes 1, the rest becomes 0 for that value. So you normalized it, scaled it, and then you calculate the individual variance as well as cumulative across all data points, plot them, and then see which has the highest variance. Remember, principal component is nothing but which has the highest spread or variance in any of the directions, and identify those directions we have seen visually. And then set a hyperparameter. So I'm using the term hyperparameter. Anybody can explain what is hyperparameter? Anybody knows what is hyperparameter? Okay, it's a parameter that we configure. The machine learning expert, whether you or me or whoever is building that model, configures that value. It is not automatically computed. So it is a manual decision making or configuration parameter. So you draw, okay, I'll take 80%, 90% of highest variance as my threshold to compute the principal components or the variances. And then you plot the heat map just to visually see the correlation across each set of 2 variables just to see. And then we plot the principal component values for the top 5. So it's essentially 5. You can imagine as a 5 by 5 matrix and plotting those values. And we can generate a PDF, right? So I think I need to do better on my timing. So let's go to the code and understand the code. So I think it's the V2 that I took. All right. I guess you can see the screen. All right. So obviously, let me ask this question. How many of you among the 61 students that are in the session right now, how many of you have not coded any code at all so far? None? So all of you have coded. So if so, naturally the first step in any code is to import the necessary libraries. So language itself has a built-in libraries. Still you have to import them. These are like your library modules, where the method or the function that you call is coded in that module. So you use that module and that method implemented in that module. You put out that code or that function name with the module to invoke that method and pass the necessary formal parameters to execute. So these are all the libraries. Which are all the libraries that we are using? Pretty much all of them are AI ML related, except one or two for image processing. So pandas, pandas library for the data manipulation of AI and ML, one of the core fundamental blocks in your life. If you're planning to build AI ML, you need to know pandas. It's entire data manipulation, metrics manipulation, all that. NumPy is numerical pi, all the computations and calculations, vector algebra, statistical mathematics, all that. Matplot, that is essentially plotting, the mathematical library for plotting. And Seaborn as well is some sort of plotting, all those pie charts, bars, you name it, right? Curves, lines, etc. And this is the method for standardizing, essentially part of the sklearn and the scikit, which is one of the first open source Python libraries for the AI/ML machine learning models. So essentially data pre-processing, the standardization or standard scaling normalization is part of the pre-processing. One hot encoding is essentially converting your categorical values into numeric values is called one hot encoding, because you're using, like I said, if you have 10 categories, you will have 10 columns added, each column having 1 or 0. And if that particular data row has one category value, that category column would become 1, the rest of the category columns would be 0. That's one hot encoding. And then of course PCA library. PCA is entire 10 steps that I talked about, computing the mean, standardizing each sample, then identifying the correlation, covariance, and then doing the eigenvalue decomposition, and then arriving at the principal components. All that 10 steps that we went through are just one line call in this code, and that is implemented in the PCA library as part of the sklearn decomposition module in sklearn, right? Then these are the transforming the columns and rows, again part of the sklearn. And pipeline, it's not needed. It's actually, I was using for something else. So this import, even though is there, is not used in the code. And the next two are related to the plotting, mathematical plotting library, to add background watermark, and then to add legends, and to add some offset to the legends, to put the legend whether on the top bottom corner or top right corner, bottom right corner, etc., etc. Right? All right. So next, let's get into the configuration part quickly. So I'm defining few variables which I would be using. For example, I'm plotting. In my plots, I'm using a watermark of this lab, GPRS Advanced Applied AI and ML Industry Projects Lab. And there is a logo that I've created, and that is used as a watermark in each graph. And this is actually the text that I've used. Earlier, I was trying to put text, but later I changed it to a PNG. So that's a PNG here. And that you can see is available somewhere here. It should be. Right? Where do you see that image? Here. So this is a file name. So I'm setting the file name to a variable, right? And then I'm defining the data path with the file name. Since it is in the same directory, you don't see any directory names, it's just the file name. Then the part of the pandas, right? So let's see, yeah, part of the pandas, you can, this method to load or to read the CSV file. You can read text files, you can read all sorts of files. There are 5, 10 types of formats that you can read. So CSV is the easiest and fastest, right? So most of the data that you can extract from the legacy systems that have been running for decades, you know, all those mainframes, etc. They all support generating data, existing data, whether in the they are already there in the file format or in the database format. They support generating in CSV format. Hence, CSV has become popular. And your databases can easily ingest the data or egress the data as well in CSV format. And then, so a little while ago, I was telling you, right, 79, if you do this line, you would get 80. So you'll have to tell them if there is an index column name with index, don't consider that as a reserved key, but count that as one of the columns. Also, same case for ID. If you use that for ID and index, then you would get 81 columns. That's what AIM's Kaggle website claims it as 81. But right now, it's not much of significance for us because we're looking at reducing anyway the dimensions, right? And then here, the next 4-5 lines are essentially to print the names of the columns. So you got the cleaned columns, right? By converting the column names from the data frame to list, then you got the cleaned columns. And then, you know, this is a 2-dimensional data. Essentially, all of these are called tensors, right? Tensor is a high dimensional data. So it could be 1-dimensional. When you have 1 dimension, it's essentially a scalar, and you have multiple dimensions, or 2 dimensions, it's a 2-dimensional data, meaning 2 dimensions. And then if you have 3 dimensions, it's 3-dimensional, beyond that is a tensor, right? 4 dimensions, 5 dimensions. It can have a number of dimensions. It's a mathematical term. Right? So the first dimension gives essentially the index 1 of the shape is your first dimension. That gives scalar, essentially. It gives the total number of columns. And actually, it's the vector, right? So it is the second dimension. And then you print the total number of columns, which is, you should get 80, and then the number of, or the names of the columns, right? Let's check. So we've got total number of columns 80, and then the column names, you got 80, right? Then let's move ahead with the other asks in the project. Then we want to print the total number of data samples, the rows, right? How many rows are there? 2,930. So let's see, how are we printing those values? Total samples is the shape 0. These are all the standard data frame. Shape 0 gives the count. Shape 1 gives the dimensions. Essentially, it maintains in as two separate characteristics of the shape, the data frame in pandas, right? Because of the multi-dimensionality of the data needed to be handled by the machine learning algorithms. That's the reason this library is created to make life easier for all of us, right? All right, next, we've addressed the total number of samples, 2930. Let's check out that value is printed here. It's printed here, right? And then let's move on. Where are we? Shape 0, we're done. Next is, which are all the numerical columns which have the values, digital values or digit values, and which are categorical columns, which are non-numeric and potentially categorical or ordinal, right? So again, it's easier. Take the data frame and select the data type in that data frame, integer type or float type, whether it's an integer value or floating value, and select those columns. That's how you get the numeric columns, be it float or be it integer. Straightforward, easy, just like English. That's the power of these libraries. If you were to born and become an engineer, let's say 30 years back, you did not have this luxury. We did not have this luxury of libraries. We had to ourselves create that library and then call your methods that you have coded. Fortunately, the world has evolved, right? And that is the power of open source. All of these, if you have observed, pretty much the massive computing infrastructure of any business or the companies that have the massive computing infrastructure are essentially running on open sources, be it Facebook, be it Google, be it Twitter, be it LinkedIn. All of these guys, their size of operations is billions every day. Users themselves are billions, right? And then the transaction, imagine, you typing, searching for something on Google, 1 billion people, out of 6 billion, at least 2 billion people or 3 billion people have access to Google. Out of that, at any given time, hundreds of millions of people are typing. And you expect the response to be provided back to you in microseconds, or at least seconds, if not microseconds. So imagine the scale of computations, computers, memory, connectivity, databases, the NoSQL data stores, right? So that is the power. All of this is driven by open source today. Anyways, coming back to present. So all this is available to you guys today, wrapped up as just a single one-line call invocation. And the same case for the categorical. Take the data frame, select the data type in the data frame of columns corresponding to object. Nothing but a text. It could be text, ordinal, or categorical. And then print them up. Let's see. So numeric columns are these, and then the categorical columns are these. Right? Any questions, ladies and gentlemen, so far? No questions? All right. I take it as you have no questions. Everything is perfectly clear. Right? Then what's our next question? Then identify the numerical and categorical columns with missing values. So again, take the data frame. So we are here. Take the data frame, DF, and filter out those numerical columns. So they are indexed as numerical columns, right? Because you got those values. But each of that column and each of the row of that column, see, is it null or not applicable? Is it not null or is it null? So is it not applicable of any value of that column, and convert that to list. So this should give us, what should this line give us, guys? Highlighted line? Anyone?
So it will give the list of numerical columns, sir.
Which have missing values, right? Not just the numerical columns. See here, we have computed the numeric columns here, the highlighted row, right? Let me see if I can enable the line numbers. It's not here. I think there is a shortcut, but I don't remember that. Yeah, so this particular column, line of code will give us those columns, numeric columns, that have any missing value in that column. In the same vein, what would the next line give? Categorical columns, meaning non-numeric columns that have any missing categorical values, be it categorical values or be it ordinal values, right? And then print them. So let's look at them. So as we can see here, there is no numeric column that has missing value. And then there are two columns, categorical column, that have some missing value. Maybe VNR type, I don't know what is VNR, mass, no, we can figure that out. And then I think mass VNR, what is mass VNR? Let's look at. So masonry, veneer type. Masonry is the work. What type of veneer? Woodwork sort of thing, right? So that has a missing value. Right. Now let's look at fill the numeric values and categorical values where they are missing with certain mean and missing categorical value. So we've done this, and then handle missing values. So filling in the missing values, we are here. So fill it wherever it is not available value with mean if it is a numeric column, and if it is a categorical column, fill it with missing as a text, a missing text value, because they are categorical, non-numeric values, right? We are treating all of them as non-ordinal values, right? Ordinal meaning indexed values 0, 1, 2, 3, but there's no ordinal value here in this data set. All of them are categorical values, right? And then print them. And then encode categorical features and scale numeric values. Essentially, the column transformer is nothing but encoding those categorical values. Like I said, if a column has 4 categorical values, you would add 3 another columns with that categorical value names, and then assigning value 1 or 0 depending upon what is the value for that particular row. And then you transform them, you normalize them. So compute the mean, deduct the mean, divide by standard deviation for the numeric values. Right? So that is essentially pre-processing, and that we have done. Now next is essentially try to figure out the correlations, the spread, the variance, the spread, how many directions there is a high spread or high variance, and compute the correlation of those directions or across the variables, and then using the hyperparameter of 90%, identify the PCA using some visual plotting. That is the next part. Right? So PCA is initialized using a library. Which library is that? We have imported here. Right? PCA is imported from this module. PCA module is from the decomposition of sklearn module. It's already coded. All that, you don't have to take any pain of computing the mean, variance, running through iterative loops, etc. Right. So initialize it and then fit the data or analyze the data for the principal component analysis. X is, we have read, we have transformed the X. So what is X? So one quick question here, ladies and gentlemen. Is the data contained in X 2,930 rows of 80 dimensions? Is this same as AIMS.csv or is it different, the values? Anyone? So I'm going to pick somebody randomly. Let's see. All right. Joshna 229X1A3309. Are you on the call, Joshna?
Josna, you can unmute yourself and speak with sir.
Okay. I'm not sure. Sheikh 229X1A3327. No, not double. Sheikh is not there. Oh no, Sheikh is there. 229X1A3359. Sheikh Kabir. Are you there, Sheikh?
Yes, sir. Yes, sir.
Okay, so let me repeat the question. So we have loaded the data. You can see here. Where is it? DF is essentially loading AIMS.csv. And then there is this X, where X is a result of the same data, but some transformation. So the values that are there in the X and the values that are there in the AIMS for the columns, will they be the same values? Is the question.
I think no, sir. It is not.
Okay, that is right. But why they are not same?
Because of we are using fit transform.
Right. We have transformed absolutely, the original data, and we have normalized the data. How did we normalize? We computed the variance. If you take the numeric values of all 80 columns, among them, I think around 60 or 70 are numeric values. We've computed the mean of each column and we deducted the mean from each column, and we have divided that after deduction, divided by standard deviation. We've computed the variance as well. Well, we did not do it, but the library, the scikit library had done it when you have called fit transform.
Yes, sir.
Right. So it is a normalized data which is more fit for running, training, and building the mathematical hypothesis for the not only PCA, but for any machine learning model. Right. Absolutely. Good job. Good answer. Thank you.
Thank you.
Let's move on. So we fit into PCA. So that means we are converting as is all the components, or we are letting him not to reduce any dimensions. And then we are computing the variance for each. How many variances are there? It's called explained variance ratio, right? So we'll see visually that will get clearer to you guys. So we compute how many directions there is a huge spread. Essentially, mostly it will be the same number of columns, but some number of columns will have lesser variance. So we'll see that visually. And then also what is the cumulative variance, not only for each variable or the column, but collectively when you sum it up, right? And then plot it. This is, so we were here. We have done the summation or accumulation in the next line. And then here, this line talks about transforming the image, the logo, to put it as a background watermark in the plot. And then it defines the figure size, 10 grid cells by 6 grid cells. And then it plots the range of the data from 1 to total number of variance length, nothing but your number of columns. And then it's setting the label, X, essential two axes, right? X label and Y label. The axis labels, and then it sets the next one sets the configures the name. It's also called a scree plot. It's again something that you would have to remember and get used to. And then create this as a grid, and then put the image, create the image and place this image. Essentially, we are computing the offset where to put, somewhere in the center, the watermark, and then annotate it. And instead of horizontal, image is being tilted 45 degrees, or I think horizontally in the center. So that's essentially the annotating the image to place it, and then adding it. It's called artist. These are all matplotlib methods, and then show it, and when print is, it's done. This is for each individual explained variance. Do the same by summing up entire variance, right? So optimal components, where we are saying it should be 90%, and then plot a line at the 90% of the variance, total variance, essentially cumulative variance. Again, these are the methods to plot, horizontal line, vertical line, you'll see that, and annotate it 45 degrees, right? Set the label names, axis names, and then add some legend, what blue line, red line, green line mean, and add the background watermark image. The first one is, as you can see, number of principal components. It's taking, because of the figure size, it runs up to 300, but actually we have the total number of dimensions 80. So the value for us is meaningful only till around this line here. You can see my mouse cursor moving. So for the first, the explained variance is highest, which means the spread is highest. So that's definitely the first component, right? And then the which has the highest variance is the first component. And then subsequently, as you can see, the variance keeps dropping in, spread keeps dropping in. Spread of the values of that column, that is the variance, right? So around 55 or so, that cumulative, or the variance, the cumulative variance, rate of change of variance, as you can see here, becomes plateaued out. It won't change, the rate of change of the variance value becomes lesser, pretty much minimal or zero. So your derivative value is higher here, essentially. First derivative, if you're familiar with the dy by dx, right? The calculus. And then later on, these are insignificant. What would be the derivative value of a line horizontal line? Any guess, guys? What would be the first derivative of an equation which represents a horizontal line? So when you say horizontal line, x value and y value are constant. So what is the derivative of a constant, guys?
Zero, sir.
Absolutely. So your variance, your rate of change would be 0 from this point until this point. So all these points are super important fundamental pieces, guys. You will have to start learning and keeping them. You have to live in, breathe out, sleep in, eat out these terminology and these simple fundamental calculus, statistical, and probability concepts, right? So cumulative variance up to 90%, we are drawing a line here, and that would be 55 components will have the highest spread. The rest 80 minus 55 is how much? 25. Will have minimal variance. Maybe there is a variance of those values, but that variance is maybe less than, obviously it's less than 0.9, right? This is in a standardized, normalized space, right? Some water. Okay, next. So now we know that instead of, so this is the key plot, which visually gives you the decision making for the dimensionality reduction. Can any one of you explain or help me understand your views? How do we interpret this? How do we interpret this map here for dimensionality reduction using PCA? Can any one of you wanna try explaining or reading it with an intuition? No? Okay, so yeah, go ahead. Somebody has unmuted. Please go
No,
ahead.
sir, it's me, Suresh. Like I was just making things clear. Like I think this topic was not covered for them till now, if I'm sure.
Oh, okay. All right.
So yes, sir. Please
No
go ahead.
worries.
Yeah,
Right,
yeah.
no
Please carry
worries.
on.
Right. So what it is saying here, at a threshold of 90%, the spread of values of all the columns, which are all the columns, 80 columns here, right? Let's look at these data columns. So let it open those columns. Okay, we'll come back. We'll come back to that. So we know that we have 80 columns in the data, input data, correct? And among those 80 columns, right, which are essentially, you can consider them being plotted on the x-axis, even though it shows 300, it's because of the graph size, but for us the data is up to 80 somewhere till this point. As you can see my mouse cursor moving vertically. Till this point, if you plot the spread, cumulative spread of values of each column, it has significant rate of change till around this point, and which is around 55th component. After 55, not in the same order, but 55, not in the same order as the CSV file. Let's see if the CSV has come up. Okay, so you can see there are 55, right? There are 80 columns. In this, you can see here, we have 80 columns here. If you compute, it actually shows 79. You can see here, like we said, it has ignored that index. So among those, first 55 columns, not first, some 55 columns account for the highest variance, and the next 25 columns have minimal variance. Hence, the spread, highest spread, if you take the 90% as the threshold, the first or the 55 columns are accounting for the highest spread in their data, which essentially embodies or has the latent data pattern, that is, embodies the latent data pattern that would be sufficient for us to reduce the dimensions. Still, we don't lose the data pattern for the prediction, which means the number of components we can reduce, principal components that we can reduce to, could be 55. So this plot is telling us, if you set the hyperparameter 90%, which we have set, you would have 55 principal components. 55 fields are good enough for you in your mathematical hypothesis as a dimensions instead of 80 dimensions. Thereby, you can reduce the computation time for, let's say, your linear regression to predict the value of the house that is sold in the Ames County in Iowa. That's what this plot visually telling us. Any questions? Okay. No questions. Then what we're going to do next? So we know we have done more than 50% of our job. We've identified the principal components. Now what we have to do? We have to reduce the dimensionality of the input data. We have to transform the input data into 55 dimensions from how many dimensions? 80 or 79 dimensions. So we have to transform, we have to fit into optimal components. How many optimal components? 55. That is what we have. You can see here optimal components, we have arrived at 55 here, this line. Argmax arguments, you would add 1 because it's zero indexed. So it would be 55. As you can see here, it starts with 0, right? Hence, we have to transform or reduce the dimensionality to 55 components. So that is what we are doing here in this line. And well, we are setting the components to be 55, and then we are transforming the data into 55 components. So the XPCA optimal would have 55 dimensions and 2,930 rows. And then it is computing the, and this is interesting, correlation matrix. So you have 55 components. If you consider input data matrix to plot the correlation is between how many? Any two set, right? Any two variables. So what would be the matrix size of the correlation matrix that is created out of this line? Anyone want to take a guess?
Sir, 55 cross 55, sir.
Absolutely. And what would be the interesting characteristic of this 55 by 55 matrix? Given that this matrix is a correlation matrix, So when the value of correlation is 0, what does that mean?
So they are not related, sir.
And if it is 1?
Positively related, sir.
Yeah, they are the same, right? And if it is -1?
They are unrelated, sir.
They're opposing. They're like inverse proportion or inverse. They are related inversely. If one goes up, other comes down. Negative direction, right? -1. So principal components are supposed to be related or not related. Supposed to be correlated or not correlated. They're supposed to be not correlated because they are independent. When they are independent, they are uncorrelated. So having said that, can you guess what could be the name of this matrix and where will this matrix have values, some values, and where will, well, what would be the value of this, values of this matrix, 55 by 55? It will be either 0 or 1 or -1. Let's say -1 is not possible. So it will have only zeros and ones. So where will be the ones and where will be the zeros for this correlation matrix, which is transformed as a principal component matrix? Anyone want to take a guess? You can take a look at the picture. This picture is actually organized as a matrix. So it's a diagonal matrix. So it will have one value where, red color, where it is plotted against itself. So if you take the components of 55, 0 to 54 are plotted on the x-axis. The same 0 to 54, which is 55, are plotted on the y-axis, right? The matrix, right? So if you consider the correlation index or correlation ratio of component 0 with itself will be 1 or 0. Anyone? Correlation of component 0 with itself would be 0 or 1?
1, sir.
1. You can see 1 here. It's a heat map. Red color means 1. You can see here, red color 1. So 0 versus 0 would be 1, red color. The same way, 1 versus 1, 2 versus 2, 3 versus 3, 54 versus 54 would be also 1. And the rest all 0 versus 1 to 0 versus 54 would be 0 values, which is blue color. You can see 0 blue. Hence, you can see the entire plot as 0 because they are uncorrelated. They are independent dimensions. Make sense? So that is essentially the correlation heat map of all the principal components. Any questions, guys, here? Girls and boys and girls. Any questions in this map or in the PCA so far? The next one is just plotting 5 data distributions, normalized data distributions, which is called pair plot. Any questions here? You have 5 more minutes. I see somebody has typed something. Let me see. We have installed Visual Studio Code 2. Okay, so that's Vishnu. Okay, fine. Any questions here? So I'm going to pick one person randomly, ask me a question, right? And I hope you guys don't mind. Let's see. Who is this person? Illuri Var, I can't see the complete name. Is it Varaprasad? 229x1a3395. Can you unmute yourself, please? Illuri, is it Varaprasad? Are you there in the call? Okay. Anyone want to ask a question? Unfortunately, I can't get Illuri. All right. Cool. Let's move on to the next one and we'll wrap it up. So the next code cell essentially plots the principal components, also called pair plots. First, 5 principal components against each other. It's a mix and match combination of the first 5 principal components. So the first 5 principal components have the top 5th highest variance in their respective data distribution, right? So we are selecting the first 5 principal components, topmost variance, and then we are fitting into this variable, and then we are creating a data and then a data distribution of the combinations of these principal components, and then plotting them. Right, just a second. Okay, right. So here you can see on the x-axis, principal component 1, component 2, component 3, component 4, component 3, 4, 5. And this is the data values, standardized data values for that, right? And would have been amplified as well, right? These are essentially standardized, meaning the values would run probably some house price would have been standardized from hundreds of thousands of dollars to few thousands, right? One of them, the other then could be the area. Other one could be the probably the common area, etc., etc. So you can see the data distribution of principal component 1 against component 5 in the bottom left corner, this portion, right? You can see my mouse cursor moving. This is the pair plot. So pair meaning 2. We are taking 2 components and plotting the distribution of data of those 2 components, right? What's the value for those 2 components, right? In a 2-dimensional plot. The same way, it's just plotted for first 5 components. So component 1 against 5, component 1 against 4, component 1 against 3 here, component 1 against 2, and component 1 against 1. So this particular map here, the distribution plot of component 1 against component 2. So let's look at individual the diagonal components here. PC1 versus PC1, PC2 versus PC2, PC3 versus PC3, 4 versus 4, 5 versus 5. So are these maps, are these plots, distributions resembling anything, guys? Looks like some bell curve. Have you heard about bell curve? It's a Gaussian distribution or normal distribution, right? Because it is standardized. So the mean is 0 and the variance is, how much is the variance for a Gaussian distribution?
1.
Absolutely. So your entire, it's also probability density. Essentially the entire area of this distribution would be how much? 1. That's the probability. So that's interesting to note that it's also in a way called central theorem. I'm not sure if you read that. irrespective of any pattern of distribution, as the data volume is high, the distribution of the data for such a high volume can be represented using standard normal distribution, nothing but the Gaussian distribution. These notions are pretty powerful, fundamental, and basic concepts for you guys to have mastery in machine learning, artificial intelligence, if you want to build career. So whenever somebody says this, it should be on your tongue tip, or tip of your mind, tip of your hand as well, right? So this is an interesting pattern. This is like, the distribution of data itself is like a Gaussian, a normal distribution, standard distribution, like a bell curve, right? All right, and then the next one is you can create a PDF of this entire code and image. If you have installed the PDF plugin, it's called NB Convert, and that has been created here, and it's beautiful. This is what I would like you guys to upload to the assignment of this week that is assigned to you guys. You can see all the plots, code, data, everything, right? So I think this is the first class where I have been successful in completing on time, and you have been pretty much disciplined, successful in joining the call on the scheduled time as well. Any questions, guys? Is it becoming, or is it appearing like alpha, beta, gamma, like Greek alphabets, or are you guys able to follow something and pick up some terminology and understand it? Be honest, guys, because I want to fine tune my approach of the code as well as the speed and the content in the slides. Any feedback, guys? Reduce the details or increase the details, reduce the slides and be superficial. Professor Suresh, I welcome your inputs as well, if you want to give any input, so that my intent is that there is some takeaway for each student when they spend each week 3 hours.
Yes, sir. The way you are like going the flow, it's fine, sir, actually. And even in fact, it's very clear and understandable. I guess like students once practicing, like they are what I can say is, if they start doing one by one assignments, definitely they will come to know the importance, and they will try to find the ways how to submit these assignments, and at that time, if I feel like they will get the doubts actually.
Sure.
And this flow, this is fine, sir. Actually, the pace of your instruction is like it's pretty comfortable.
All right. All right. So, students, any questions, any inputs, any feedback, good or bad, doesn't matter. Nobody is perfect. And learning is never ending. Learning goes all the way till death. So let me know if there is something that you guys want me to incorporate. I'd be more than happy to do so.
If someone can unmute yourself and convey the things. Kabir, anything to convey in terms of sir asked? Are you there, Kabir?
All right.
Yeah, Vishnu, you two can provide the feedback, like anything regarding this course content, the delivery of sir. You can unmute yourself.
Sir, it's good, sir. But we can say that as we don't know most of the topics, so it would be better to go somewhat slow, sir.
Okay. So I see your point, and it's a valid point, and I also felt so. So if you can help me, which area that you want me to spend more time on the core algorithm or something else, on the code or on the concept side? Where do you want me to go slow, or both?
Sir, I would like to mention in concept side, sir. It's better to understand the concept, sir.
Okay, sure. I will try to spend more time on the core concepts. So I will not address the project on Saturday. I will dedicate the entire Saturday session to the core concepts. So far, also, incidentally, last class, yesterday's and last week's, these are little pretty loaded, heavy subjects, right? And I also felt that I gave lots of introduction in yesterday's session, particularly in helping you understand what the heck is machine learning, what are the stages. I spent a lot of time there, and intentionally so, because you guys are in 5th SEM, and I don't think you had an end-to-end conceptual understanding of all the stages of machine learning. My plan was going forward only to spend more time on the core algorithm. For example, next class, next session would be the linear regression. So try to understand more on the linear regression. But yes, your point is taken, and definitely I'll try to spend more time on the concept or algorithm description on Saturday classes. Thanks, Vishnu, for the feedback. Anything else, Vishnu?
Nothing, sir. Thank you for responding, my doubts.
All right. So we've gone 6 minutes beyond the scheduled time. Anything else you would like to add, Professor Suresh?
As of now, nothing, sir.
Right.
Like anyhow, sir, like for these guys, in the upcoming week, we'll be going to start the 3rd unit, sir. So at
Right.
that time, I feel like for them it would be easy, like the concepts which you teach and which they study. I guess they will be on streamline, sir.
Sure.
Yeah.
Excellent. So then I believe next week we have break 1 or 2 weeks. Please check the first course handout. The schedule is very clearly published there, and I would be sticking to that schedule. I think we have break for next 1 or 2 weeks till 22nd or so for the internals. I wish you all the very best for your first internals. Remember, first internals are the always golden opportunity to score high. It would be easier usually, and it would be also not that complex, right? But do not postpone your preparation and waging the war against the internal to score your highest grades. Do it in the first internals. Usually the last internals in the semester would be most complex. So wish you all the very best, and we will meet for the linear regression after your internals. Meanwhile, try to complete this assignment and upload your code PDF file onto your respective assignments on the Google Classrooms. Thank you, guys. Have a great weekend ahead, and have a great Vinayaka Nimajjanam.
Thank you so much, sir. Thanks for the session.
Bye, guys.
Have a good day, sir. Thank you. Bye.
I'm stopping the recording. You can exit, guys.
Yes, sir. Thank you so much.
Thank you.